And thank you for coming to this session, hopefully for the next hour or so, and then we'll open it up for some questions. It's about vectorization, whether you want to use it regular RAG or with graph. We'll explain the difference between them, tell you when to use one versus the other, and hopefully you can ask a lot of questions as well. There are not a lot of people in the room, so feel free to ask. Don't wait till the end, but if it's something that I'm going to cover during the hour, I'll tell you to be patient and give me another few minutes, and I'll get to that point during the explanation. But if it's a question that is keeping you from understanding what I'm saying, please stop me. It's important that you understand what I'm saying, and that would be great. Thank you. My name is Lino Tadros. If you haven't been to any of my sessions yet or the workshop, I've been in the industry for about 33 years. I'm currently the co-founder and CEO of a company called Tahubu. We specialize in consulting and training on data and AI. I've been doing AI and machine learning for about 9.5 years now, way before it became very nice and very sexy. So we did it during that time. And I started my career in a company called Borland. How many people are old like me? All right, sounds good. So I worked for Borland for 10 years, working on the C++ compilers in Delphi. After that, I started my own companies. And now I actually love working as a consultant, coach, and a trainer for a lot of different companies here in the United States, in Europe, the Far East, and New Zealand, and Australia as well. I've been a Microsoft MVP and a Microsoft regional director for the last 24 years. What does that tell you? I'm old. All right. Just 30 seconds about Tahubu. We are a boutique consulting company specializing in data and AI mainly, whether you want to use like Snowflake or Databricks or Fabric, and also all the flavors of AI, not only Azure, but also AWS, Google Cloud, and others as well. We architect intelligent, secure system for enterprise level AI, not the ones that actually ask a question, you get an answer back and we're done. No, real stuff that contains heavy security, have compliance with HIPAA compliance if it's a healthcare company, PCI compliance, and others for fintech, and so on and so forth. We take care of all the security, including the column level security, row level security, and masking, and everything else as well. Our team combines actually deep technical mastery with strategic vision, backed by decades of experience doing this in multiple public clouds as well. So if you need to talk to me about any of the stuff, please feel free after the session to reach out to me, and I'll be more than happy to explain some more as well. What is the agenda for the next hour? I would love to have a chance to explain to you what RAG is all about. How many people here are very comfortable with what RAG is? All right, so about maybe 10 people. That's great. Don't worry, if you don't know what RAG is, we'll explain all that. And then part of the RAG, we have to talk about what embedding is, what vectorization is, what works and what doesn't work, what's demoware and what's not demoware. So all of that stuff would be important for us to discuss. Why RAG does not work. I've been nice, I said sometimes, I should say most of the times. What is graph RAG and why people actually started looking into that. Why is graph sometimes, again, most of the times, a better option for enterprise ready. And then we will do a demo of RAG and we'll do a demo of graph, and I'll let you make a decision what's best. I'm not saying that RAG is not the best thing for your company. It all depends on a lot of things, especially the amount of data that you're trying to vectorize and so on. So we'll talk about all of that. I'm going to start talking about the RAG utilization patterns. And RAG stands for Retrieval Augmented Generation. Retrieval augmented generation, a lot of people, when they think of RAG, they always think there is documents coming in, database coming in. Actually, it's a lot more than that. The fact that you're actually writing a prompt and you give it an example, that example is RAG, right? So if I say, for instance, like, I would like you to tell me who won the Oscars, and by the way, I would like to give you an example of how I would like you to send me that. I want you to start with this sentence and then create a bullet points. So what I'm doing there, I'm giving you what we call a one-shot prompt. And sometimes it's too complicated, so I'm going to give you 2 or 3 examples in the prompt itself, and that's called few-shot prompts, all right? That means I'm asking a question, and I'm giving you a hint of what I would like you to respond in a specific format and all the stuff. These are called one-shot, few-shot. And of course, most people that actually are asking the LLM directly without giving you any examples, these are called the zero-shot prompt. Zero-shot prompt, I'm counting on the LLM understanding what I want and figure it out, all right? So each and every single one of them is an example of RAG. If you put that in the prompt, that is RAG, all right? It is not just one pattern. There is a lot of different patterns for RAG out there. RAG is definitely the most used one for doing augmentation in the system. And it actually has 4 different things. So whenever we talk about the word RAG, it's 4 different things that you need to be aware of. And they all have to happen in sequence like this. You cannot skip one or the other because it has to work this way. The first one is called the ingestion. You have to load the document. You have to load the text. You have to load the image. You have to load the video. You have to load it first. That's the ingestion part. The second part is, we call it the chunking. What does it mean? I think if you came to any of my sessions, I like to give this example because it explains exactly how RAG and embedding and vectorization work together. So I'm going to talk about an example of, let's say, for instance, I want to ask a question to the latest LLM, for instance, and I'm going to say, what did the president say about medication in the last State of the Union address? Most LLMs, when you ask that question, it will come and tell you, like, I don't know, because I was trained with information from 224, and I don't have access to what the president said after that in a State of the Union address. So I'm going to say, okay, let me help you out a little bit. So I'm going to go to the whitehouse.gov website, which by law, after 72 hours max after the speech, they have to make the whole speech available as a PDF. That's just laws in the United States in here. So I went to whitehouse.gov, and I found the latest State of the Union and downloaded the PDF. The PDF was 84 pages, okay? So can I actually use RAG with that PDF? Remember what I said? It could be a one shot, few shots. So maybe I can ask the question again, and I'm going to go ahead and copy and paste 84 pages into the context window itself. Hopefully my LLM have enough tokens for that. So maybe it's 128,000 tokens are allowed. I don't know if 84 pages are going to exceed that or not, but I can give it a shot. For my luck, the model that I was using will allow 84 pages to be loaded inside of the prompt with my question. All right, great. How expensive is that question? Because I'm paying tokens for all the content of my questions and the 84 pages. So that's a very expensive question at that point, right? And finally, I can ask the question, what did the president say about medication in the last speech? And the best of the models will come back and say, nothing. He didn't mention anything about medication. I said, that's not true. I remember he talking about medication. Problem is, it actually, he did not use the word medication. He used prescription drugs. He used COVID. He used other words for Medicare, Medi-Cal, whatever, but he did not mention anything about the word medication. So it was not able to make the relationship. So how can I make this better in both ways? Not only to search for medication, but I want semantic search. I mean, the concept, what I'm looking for, I want the system to understand what I'm looking for. So if I'm asking for medication and there is no medication, but there is prescription drugs or Medicare, something similar to that, I would like you to respond, tell me what he said about that in the speech. And this is where embedding and vectorization will come in handy. So remember, there are 4 stages. The first one we talked about is the ingestion. That means I'm bringing the whole file in, or multiple files, okay? And then the second one is the chunking. Chunking means I'm going to take these 84 pages, folks, in the PDF, and I'm going to chunk it into smaller pieces, okay? I get to choose how I want to chunk it. There is like 7 or 8 different methods of chunking. You can make it based on recursive text, on tokens, on characters, on paragraphs, on markup text, so you can stop at a paragraph. There is a lot of way to do it. And it all depends, of course, on your document. So with experience, you'll be able to open a document. It's like, I think this method will be the best for the chunking because I don't want to split a sentence in the middle and lose the meaning of it in another chunk. So you need to really stop at a nice place that I don't actually have to split my idea. So once you find out what is the best way to do the chunking, we run the chunker, all right? And now the 84 pages, if I say every maybe 500 characters or every 1,000 characters, let's say it came up with 1,000 chunks, all right? Out of 84 pages, I got 1,000 chunks. All right, the second thing is done. Now we have our 1,000 chunks. And now the third one comes in, which is I have to create an embedding. What does the embedding mean? Bear with me here for the next 2 minutes. This is probably very important for our session, which is vectorization, of course. Embedding means I want to use a model, but not a generic model like GPTs and Sonnet 4.5 from Anthropic or Meta. No, I'm actually looking for an embedding model. Embedding model, what it does, it takes every one of these 1,000 chunks and it will create a huge amount of floats, numbers, for each chunk that represent all the attributes inside of that chunk. So there are a lot of different embedding models. Some of them are expensive because they have a lot of dimensions. Think about it this way. This is how I'm used to explain it for the last few years, is that if I want to actually represent a sphere, a ball, in multiple axes, how many axes do I need? 3, X, Y, and Z. And I can definitely put a ball in there, a sphere, right? I want you to think it's not 3 axes only. I think it's 1,536, or it's 3,072 axes. I know it's mind-boggling to think about how many axes you can display in, but this is how big the algorithm is. So something like 1536, for instance, from the one that come from OpenAI, like Data 002 embedding model, or 3 small, and there is a one called 3 large, which is 3,072 different dimensions, the axis of the bottom. We'll take the smaller one, which is the 1,536 axis. Now I take the first chunk and I say, embed that using the model and give me 1,636 flows that represent this chunk. So if my chunk says, for instance, I have a golden retriever that is golden colored, 20 years old, very nice, every single thing I said about that is an attribute that will be represented in one of the 1,536 flows. So I'm going to take all of these numbers with the first chunk and I'm going to place them on the sphere, okay? All over the sphere, based on their attributes. Now I'm going to go to the second chunk. Embedded was just costing me money. It's not free to do embedded. Of course, there's free ones from Hugging Face, I'm talking OpenAI and Tropic and Cohere. You have to pay for that stuff. It's not as expensive as the generic one like GPTs and stuff, but you still have to pay for that. So go to chunk 1, gives me all these numbers, I put them on the sphere, and so on and so forth, and I finish all my 1,000 different chunks. Now the sphere is full of them, like millions of different flows all over the place. Somewhere on this sphere now, there is the word prescription drug, and then maybe not too far away from it, COVID, and then maybe not too far to the right, maybe Medicare, okay? And then the chair and the army is way somewhere else on the sphere. It's too far. It has nothing to do with that. But you can imagine, based on 1,536 different axes, I need not only the distance, but because of all these axes, I need the cosine, the angle between the occurrence of that word or that attribute itself. Does that make sense? It did. So now I did my job ingesting, I did the chunking, and I have my ball, all right? The sphere has all of the stuff, cost me a lot of money, right? Maybe it's not a lot of money, it will cost you $1 if it has a significant amount of data in it. I don't want to do this again, because it didn't change. So I want to save this somewhere, so I don't have to do this again. So the question sometimes people say, do I need vector databases or vector stores? The real answer is no. But every time you want to run this, you're going to have to do it better, put it in memory, and figure it out. Next day, if you want to, you have to do the whole thing again. So that's why we need vector stores, because when you're done with the embedding, we take the sphere with the millions of floats on it, we take it as is, and we put it in the database, so I don't have to do this again. So tomorrow, if I want to use it, I just load the whole thing again from the vector store, and I start asking questions again. So now, what is about my question? My question is, what did the president say about about medication? What do you think the system does with that? It has to use the same model the whole thing was embedded with, which is, let's say, the 80002, and it will embed the question. So now the question is embedded, and the question now is laying on top of the same sphere. And then when you put it on top of it, it would find out that the word medication that you're asking about, I don't have something exactly matching, but within the area that I said it's okay, which is like cosine 0.2, and the distance can be 0.003, the hits, COVID, prescription drug, and Medicare showed up within that distance on the big sphere. So I'm definitely comfortable returning that as part of the chunks that summed up. So now, from the 84 pages, from the 1,000 chunks, there are 4 chunks that has to do with medication. One chunk over here that has prescription drug, a few chunks later talks about Medicare, all that stuff. So the nice thing now that I figured out, I'm not talking to the LLM yet. All the stuff is between me and the vector data store in the embedded. Now I got my 4 chunks that are talking closely to the medication, only my question, and these 4 chunks will end up going to the LLM. Now I'm saving a lot of money. I'm not sending 1,000 chunks and paying for all that money for GPT-5, for instance. I'm only sending like 4%, less than 4%, but 0.4%, 4 chunks with the question gone. Now the LLM knows what the question is and have enough few shots that contains data about prescription drugs, COVID, and all that stuff Now the LLM can very proudly say, yes, the president talked about this, about prescription drugs, and the prices go down and all that stuff, and Medicare, blah, blah, blah. And you can answer the question. And then you feel like, okay, great. And you take a look at the tokens, it's way different than when we loaded the entire 84 pages. It's like 1/1000th of the price and the amount of tokens that we use. Then, so that's the idea behind embedding vectorization, just to give an example about it as well. And feel free to ask, because I'm going to be talking about that in more in depth, but that's the concept of why we do embedding and we do vectorization. The current RAG pattern, for instance, the typical RAG differs from original RAG in replacing fine-tuning encoders. So you will hear this a lot when people say, I work in a legal office, or I work in a manufacturing company, and we keep RAGing the same data over and over to the same model because the model doesn't know about our stuff. All right. So you keep paying for that kind of money for the embedders, and the data changes a lot or something like that. So you would hear the word fine-tuning. So people actually are always trying to figure out, is it better to do fine-tuning or is it better to do RAGing? So fine-tuning means I'm not going to bring documents from the outside and vectorize it. No, I'm going to download the model. Let's say, for instance, Llama 3.2, maybe a small model. We're not going to download GPT 5.1, folks, okay? First of all, it's not open source. Second, it's a 16 terabyte model that is deployed all over the world, and it costs $128 million to train over 4.5 months, 1,000 different GPU machines. You're not going to download that. But if you go, for instance, to Microsoft or Llama or Docker, you'll notice there are models out there that are only 5 gigabytes, and maybe 7 gigabytes. And maybe a big one would be like 13 gigabyte max. And these are the 5.4, 5.45, 5 in PHI. These are the names of it from Microsoft. Llama 3.2, Quaid 2.5. All of these are smaller models that don't know, of course, as much as the big kahunas like 5.1 GPT and all that stuff, but they've been trained very well, and they can answer a lot of questions, especially something that doesn't require major complex reasoning or anything. Then you do with that. And it's running local and machine too. You don't have to pay any tokens for these guys. Okay. So the legal community, for instance, would say, well, instead of doing RAG and paying for all that stuff, why don't we just do it once and get it over with? That means let's download Llama 3.2, all right? And I'm going to train it with my own data. Of course, it's going to take some time. It's going to cost money, all right? Training a model is not something cheap or fast. It will take time. But at the end of that cycle in machine learning, I'm going to end up with a new model based on Llama 3.2. I'm going to call it Lino, okay? And I'm going to deploy it. Now, my company can use that model without any RAGing because it knows already about all our data. We uploaded all the last 20 years of cases in our legal office inside of the SLM at this point, small language model. And it works great. No RAGing, nothing. The system knows it. So people say, this is great. Depending on the price, I can see if RAGing is better, costly, maybe fine-tuning is better. But we notice something that some people don't like, some people don't care, which is something called catastrophic forgetting. Catastrophic forgetting is one of the things that people don't like about fine-tuning. Because when you fine-tune a model that's already been trained and enter your own data in it, it grabs that data, and for some reason, it forgets about some of the data it was trained with. And some people think it's okay. It's important for you to know about my legal system, but I don't care if you don't remember anymore why the sky is blue. I don't really care. So, but some people say like, no, if it's forgetting so much and it will impede it from actually being able to answer logical questions in the legal system, we have a problem with that. Maybe we can go back to RAG. So you have to play around with it and find out what's the best thing about that. But remember, fine-tuning could be great, but it has the characteristics of catastrophic forgetting, losing some of the knowledge that it was originally trained with, okay? All right, hopefully that makes sense. The retrieval phase itself searches relevant documents or data. It uses its content to generate informed responses. So it's worked great. You see from the image, we do the chunking, we do the embedding, we add it inside of an index, and that index can be saved inside of a vector store. And then when we do the retrieval, you take the questions, embed it again, put it on top of the index in the graph itself, and then the LLM will get the chunks and will be able to answer the questions like I said. The benefits of RAG: enhanced accuracy, because it has a lot more information about my system, and my HR handbook now has been vectorized, so the system knows when we have our 8 or 9 vacation days per year. They know, for instance, what the dress code in the office is. LLM will not know that. It will be generic. It might not match what you have, but if you did that with RAG, it will know exactly what the laws and the rules are inside of your company, for instance. Contextual relevance, very important. Scalability as well. So you can actually have that scaled in multiple regions, for instance, if using Azure or AWS and Google Cloud. In general, we notice that RAG is very much ideal for Q&A question system, like customer service, stuff like that, content creation, blogs, press releases, marketing, newsletters. It works very good for that. And data-driven decision making. It combines the best of both worlds, the robust data retrieval and the creation, of course, of the response generation itself. This is just a quick graph of how we do it inside of Azure. It's very similar, by the way, if you use AWS or Google Cloud. They're not going to reinvent a new system. RAG is RAG, which is, you notice on the left side of the screen, there are data sources. You might have data inside of a SQL Server database or Cosmos DB or PostgreSQL or any database. Or you can have an app that's actually sending data. Maybe it's an IoT device every 5 seconds sending information about pressure and temperature in an oil rig, for instance, and I want to capture all of this information. Or it could be files like CSV files, Excel spreadsheet, PDFs. All of the stuff could be coming into the system. Most people, at least in the enterprise, they like something that they can retrieve the history of the question and answer really fast. I always say Cosmos DB is winning in this one because Cosmos DB is pretty much the only database that have a less than 10 millisecond retriever speed. And that could be very, very useful when you have a lot of conversation. Let's say, for instance, I've implemented this for a major university here in the United States, and they have 25,000 people using the same system to ask questions all day long. All right, so each one of them, of course, of the students and the teachers and so on, they will have their own secured channel that they can save all their data inside of Cosmos DB, for instance, to be able to retrieve that in less than 10 milliseconds, to be able to deal with the history of maybe they stopped and they want to come back next week to finish up the conversation. They will retrieve that from Cosmos DB and they will keep going forward with that. But you'll notice in the middle there are two pieces. The piece that you have to do beforehand, which is the piece that you will tell the system, do the ingestion, do the chunking, do the embedding, and save it in the database. That has to be done first. And then there is the piece where somebody's coming in to ask a question maybe next week. So we'll embed on the fly that question, put it on the sphere of the vector database and find out based on the cosine and the relevancy, what is the closest to what I asked for, and go from there. It can get a lot more complicated than that, and we will talk about it. I want to prepare you for the rest of the talk because this talk about vectorization with and without graph. Most of the time when you go see a YouTube video or you come to a conference like this, because we only have 1 hour, what do? We upload a couple of PDF files and we start asking questions and everything works great, right? But in real life, when enterprise hire us to do this, they don't want to load 2 files. They want to upload 250,000 files, 500,000 files. So the question now, does RAG continue to work when you have that type of files being uploaded and vectorized? And the answer is not very good. RAG doesn't do very well with that, all right? The reason for that is because the mechanism it uses, like I told you, with the cosine, the angle, and the distance, you might actually be number 200 in the results coming back, but you said you won the first 10. And you didn't do a re-ranking. That means you didn't order the priority. So you end up losing some significant valuable answers coming in from the chunks because it's not within the 10 that you asked for. I just won the first 10, but there is 200 coming back, all right? So maybe I can do a re-ranking. Even with the re-ranking, it can actually skip a lot of the ones that it's supposed to get. That's why when we get to the part about the graph itself, doing the knowledge graph, instead of actually doing it that mechanism, what it does, it actually look at all the 250,000 documents and start creating entities and communities. So it will take a look at some keywords and start building around that. So when I ask, for instance, about an entity in here, it will look at everything that has to do with this entity. So it can focus on that and do the RAG based on the entity, not based on 250,000. Way too much distance between these documents to be able to get you meaningful results. Yes, sir?
Hold true against Euclidean as well.
Against what?
Does that hold true against Euclidean as well?
Yeah, well, there is a lot of different mechanism. My favorite one is disk ANN, which is the approximate nearest neighbor, which PostgreSQL and Cosmos DB uses. We just use a lot of different mechanisms. The newer ones are much better for the indexing to get you the fastest index possible. But you can do it with other mechanisms. And even if when you go to Azure, you open up a Cosmos DB and enable that stuff and PostgreSQL, you will have a choice to use disk ANN or Clifton or what's you call it. There is another one I forgot, based on the cosine. There's a lot of different ways to do it, but I prefer to do the disk ANN. It proves to be the faster one in all of them. Does that make sense? Excellent. Keep the questions coming. That's great. Yes, sir.
K-nearest. The third one's K-nearest.
K-nearest, yes. So there is a lot of them, but like I said, if you take a look at the ANN one, disk ANN, that's used for most of them right now, and it actually ends up resulting in the best performance. All right, so now let's talk about what RAG is not. All right, so this is important, okay? At its core, RAG is a powerful information retrieval system, of course. In plain English, really, is that RAG enhances the output capability, whether it's based on one shot, multiple shot, the chunks coming in. Enhances the output capability of the language model in knowledge intense tasks. RAG is a zero-shot retrieval augmented pattern. You don't need to put anything in the prompt. It will go ahead and do that by bringing the chunks directly from the retrieval. So you don't have to give it examples. That will be the context that will be fed into the prompt before it goes to the LLM itself. The problem is it's easy to confuse RAG with other patterns, especially since RAG has entered the vernacular like Kleenex is to tissue. Everybody talks about RAG is the way to augment generation. Actually, there is a lot of other models like ART, there is RALM. There is a lot of different ways to do it, but the most famous one is the RAG system to be able to do that, and that's what the industry is using right now. So be very careful with the next maybe 6 or 7 different points about the RAG pattern is not the following things. It is not the one pattern to rule them all. There is other patterns that you can use to do augmentation. It is not a pattern that uses tools or plugins. It is not the ART pattern, for instance. The retriever, the generator, and the retriever data source are the only components. So like sometimes when you create an agent, I'm sure you've heard agents all over going to different sessions and so on. Remember, RAG will be just one step inside of your agent. It's not going to be the agent. It's going to be one step in the agent. You know why, folks? Because the agent has to have the ability to loop and go back. RAG doesn't do that. So it has to be only one step inside of that agent to do its job, but something else has to loop. RAG does not loop. So remember that as well. A multi-turn pattern, which is what I just said, for example, it cannot run in a loop by itself to refine the context data it's using or verify that its output is valid or reasonable. Chain of thought. I was given an example in a previous session about the chain of thought using the new models for reasoning models, all right, like O1 and O3, and there is a lot of other one like DeepSeek and so on. These are reasoning models. So, for instance, if you want to see exactly how a model thinks as a chain of thought, usually when you mention something in the prompt saying, give it to me step by step, whenever it sees the word step by step, it knows that you want me to really think about it in a reasoning manner and to find out. So I try sometimes in workshops to have an example saying, I had my keys in my hand and I walked around the house, I tripped on the couch and I fell down. I got up, opened the door, and went to the swimming pool and sat down on the chaise longue, and I fell. So now my question is, like, I lost my keys. What are the possibility where did I lose my keys? And if you ask questions like this, you will notice if you say verbose equal to true, the reasoning models is thinking about what is all the possible places in the house and outside of the house that you could have possibly lost your keys based on bumping into this, based on the surface of the ground. Maybe if it's a wood or something, maybe you would have heard the keys, but he didn't hear the keys and he kept going. Maybe it was outside because there is a lot of noise. All of these things happen in the reasoning model, which is unbelievable. And then we'll tell you, like, you have a 90% chance you lost them outside, right next to the pool. So maybe take a look at them over there. So the reasoning model is really amazing, and you can see what the system is doing. And it's nice for us to be able to see, at least as an example, what the system is doing by turning verbose equal to true and see the tracing of how much it goes back and forth to find out exactly what are the possibilities of me losing my key based on the events, one by one, chain of thought. React, though RAG is often used as a step in the plan execution by React pattern, that's, like I said, because there is no looping in the RAG itself. The only pattern for retrieval augmented, it is not the only pattern of what we call RALM, which is retrieval augmented language modeling. RAG also is not a pattern for tasks where the data changes frequently. Can you imagine spending all that money on the embedding, putting in a vector data space, and the data changes tomorrow, all right? And then you have to do the whole thing again. And sometimes people tell me, what about, I have 250,000 documents that I vectorized. I paid some good money for that, but 10 documents next week will change. Am I supposed to go ahead and do the whole thing again? Of course, that doesn't make sense. So hopefully the index will allow me to take these 10 documents that got indexed out of the index and put in the new one. That requires what we call record keeping. Record keeping means you have to add document IDs on every single chunk to be able to recognize that which ones change and do a surgery to take those out of the index. Because if you remove the index and bring everything back in, you're paying for all the embedding again, and that's not going to be a good thing. All right, that's going to be too much money. And I want you to remember what I just said right now, because when we start talking about GraphRag later on, there are a lot of flavors of GraphRag from Microsoft, from other companies, and the one from Microsoft has problems, and that is one of the problems about it cannot actually do this part. It actually have to do the reindex again from the beginning, so it's extremely expensive. But remember, that's not a product, that's a research project, all right? Microsoft did not release GraphRag, so put that in mind. We'll talk about it in a little bit as well. I'm sure it will change. It's too expensive. For instance, I took 7 books from the Dickens books that we all read probably when we were kids and so on, which is pretty good sized books. And I said, I want to try it both ways. I want to actually use like GPT-4o and an embedder, for instance, like the 8802 embedder. And I would like to see if I vectorize this, for instance, how much it will cost me and how many tokens will be used to vectorize the entire 7 books from the Dickens group. And I did that with RAG, and it cost me 71,000 tokens. Do the math, and probably it's like less than a buck, probably, or something like that. I did the same exact thing with GraphRag from Microsoft, and it's 1.2 million tokens for doing exactly the same books, all right? And if I remove one of the books, you'll have to pay the same exact amount of token because it cannot actually do that. In the future, that will change. That's why there are competitive knowledge sources out there from a company like Neo4j. There is one called LightRag that does, currently at least, a better job in to be able not to have to reindex everything, and the price is way down on how it does, and the indexes are surgically inserted and taken out from the final one for the GraphRag as well. So the power of embedding models. I gave you the big picture about how embedding works, of course, but embedding basically converts text to coordinates, like the 1,536 different flows that I told you about, that maintain relative distance between that text and similarities in the meaning itself. So the application for that is semantic similarity, clustering, full text search, classification, recommendation, all of that is done this way. The most important thing I want you to remember, based on what I said in the beginning of this session, is that embeddings does not store anything, all righty? It does it, and it's there. It's up to you to take whatever it gives you and go ahead and put it in a vector database, but it doesn't save anything. It just does the job, and it sits there. If you shut down your computer, it's gone. All right, so embeddings does not store anything. All right, the embedding works, like I said, you get some text coming in, you run it through the embedder model. And why do we have to pay for the embedding model that we're using? Because there is a lot of work being done in here to be able to take all the attributes in the chunk and being able to give them that float based on the attributes to place them by meaning on that sphere. So that's the very important thing. So you'll end up with a vector with 1,000, 2,000, 3,000 different dimensions of these float numbers that represent all that stuff. Is it only text? And the answer, of course, is no. So you can actually have the text like happy birthday. It will end up doing that from natural language processing. It will create the 1,536, for instance, as an example of floats. And that you do translation, understanding, sentiments, question and answer. All of these things can be possible. But can you do that with an image? Absolutely. You can take the image transformer, create a vector out of it, save it in a vector store, and you can do the same thing. Audio, same way. You can take a WAV file, for instance, and run it through an embedder, and it will actually represent all the content of that audio or a video, for instance, and put that inside of the database if you would like to save it in a vector store as well. Similarity, just to give you a little bit more an example of how this stuff works. Yes, sir, go ahead, boss.
The embedding, embedded so let's say like embedded by AI, and then you can get generated.
It's an excellent question. It's asking about if the whole thing was embedded by OpenAI, let's say 88003, can I use that somewhere else. And yes, the only thing you have to remember is whatever you did on the big sphere, you have to use the same model when you embed your question. So you cannot do the whole document with ADA02, and when you ask your question, you're going to embed it with 3 small. That's not going to work. The only requirement, no matter where you're using it, AWS, Azure, Google Cloud, that the question and the big sphere that has the entire vector both have to have used the same embedding model. Other than that, you're okay. Make sense? Awesome. Yes, sir.
How does this work with ingesting raw data from people?
Ingesting what?
Data from people.
All right. For tabular data is different. RAG is not very good with tabular data. RAG likes it when it's text coming from documents. That's why we end up using Azure AI Search as the vector store, because Azure AI Search is really good with unstructured data. Whenever there is structured data coming in, like SQL Server database, tabular columns and rows, RAG is not the best way to do something like this. Usually, we will use a different mechanism to do the augmentation, and that by having maybe an agent that will generate a SQL statement, and that's the only thing it will do. And a different agent will be executing the SQL statement. They are not the same thing. So I want an agent that knows exactly how to create good syntax SQL that understands natural language and create that SQL, and then another one that will actually run it. And I can talk about this for a while because I use it a lot for different companies, but I don't want to kidnap this session, but I'm going to tell you this. If the database have 10, 20 tables, it's not a big deal, alrighty? But if the database have 500 tables, most people I see, whether they're using LangChain or Llama Index or using GPT 5.1 or all the newer stuff, you're gonna run out of tokens really quickly, because it's gonna end up having to create the entire schema of your entire database with your entire 500 tables with all the columns in it and everything, and we will send it to the LLM, and probably much you're going to run out of tokens. Depending, of course, on the model. If you have a huge model that contains a lot of context window, it might work, but it's very rare that I see it working. That's why most of the time when people are working with tabular data, what they end up doing, they will create agents that will only focus on like 10, 20 tables of the 500 tables and call it, this is the profile agent that only knows about these 7 tables, okay? And then if you're working with a content management system, for instance, right, let's say Sitecore or Kentico or Sitefinity or WordPress or any of these guys, maybe I will look at the database and they have like 500, 600 different tables in there. I'm going to see for the news and the press releases tables, there's only like 9 tables that have to do with that. So I'm going to create an agent that only knows about these. But sometimes you need to actually piggyback on the profile tables as well. So maybe I will call this one first, get the entity of who's logged in, and then I will go to this one. And that means that I'm going to send the schema only for 7 or 8 tables, not 500. And that will make more sense. And then you have to write some prompts, and you have to really work with the agent to be able to dissect a little bit the database pieces by pieces, not all at once. If you just give it the database and say, go at it, it's not going to work. Make sense? Yes, absolutely. But remember, MCP will not do the whole job as well. For instance, there are MCPs for PostgreSQL, for SQL. I mean, there are thousands of MCP servers out there. But it will not, whoever came up with the MCP server should have done this splitting of the tables on the inside of the MCP server, so you don't have to deal with it. For instance, I know a product called Sitefinity very well, and I know the 241 tables by heart for the last 20 years. So when I created my MCP server called Tahubo SF, for instance, and I gave it to the world for free to use, so that I can go, so the marketing team doesn't have to wait for a developer. So I can go and hook up my MCP server for Sitefinity that I wrote, and people in marketing don't have to wait for development. They can just say, like, create me a blog that talks about this in 3 paragraphs, and if I approve it, let me approve it, human in the loop, let me approve it first, and if I approve it, I want you to publish on the website right away. They don't need to know what the authentication is. They don't need to know what the API is to actually publish something on the website, whether it's WordPress or Sitefinity or Kentico or whatever. They're just talking in English. That saved them a lot of time, because now they don't have to work for an IT person or developer to do all that work. Does that make sense? They just ask for it and the system will do it. And it's tabular data, but it's based on REST APIs. So sometimes I look at the API available in that tool, and I feel like I can do 90% of what I want to do using APIs, REST APIs. Great, that is going to be my RAG, the REST APIs. 10% is not available through RAG, through the API. So guess how I'm going to get to the final 10%? Through the database. That means I know about the database, And because of security, they don't enable it through the API, but I have to do it. So I'm going to write code against a specific amount of tables, and I'm going to tell my agents how to deal with that piece. The rest, I'm going to use the REST API, but my customer does not need to know at all how that CMS system work on the inside. Make sense? That's the beauty about MCP server. It can save you a lot of time for this stuff. There is one for Salesforce, one for Dynamics 365. So instead of learning the 10,000 APIs available in Salesforce, you can just open up your NLP like ChatGPT or Anthropic, like let's say the Claude desktop, and say, that's the MCP that I want to use, and then talk in English, and then the system, if you tell it, do not do it right away, you have to wait for my approval, can do that, and it will do it for you as well. So there is definitely a lot of things you can do about that. If you take a look at the graph actually on the left side, that gives you a little bit of an idea. When you read these thousands of chunks and you start placing things on the sphere I was talking to you about, the word dog and puppy will be very close on that. So when I talk about dog, but the story is about puppy, I'll probably get that back from the story. Wolf is close, but not as close. Cat might be close, but not as close as dog and puppy, because they are much closer to coffee, milk, and tea will be in the different places. They should not come back. The distance will be too far, and the cosine between them will be too far for that. That is the dog at the top, 01, 051, 06. All the 1536 or the 3072, based on the model, will be looking like that. The foundation for contextual data retrieval, again, we talked about the indexing for retrieval. The role in contextual data retrieval, I talked to you about the benefit, which is the speed and relevance in retrieving information. You don't have to be exact. So what is the best way to use RAG, folks? Should I use based on keywords, or should I be basing it on semantic search? What do you think? It's a trick question. Huh? Both. The best results we can get is to combine both. I know a lot of people say semantic search because it's much more intelligent and it knows about the synonyms and the when I ask about Apple, is it Apple the fruit or is Apple the company? So based on the context around it, the system will be, oh, he's talking about Apple the company because he's talking about stock, all right? So all of the stuff is, but keywords is very important too. Keywords is as direct access to the meaning in the data itself. So combining two. That's why when you go, for instance, to Azure AI Search, which is very good for unstructured data, but it's not very good for tabular data, all right? It's very good for PDF, Word documents, chats in Teams. All of that stuff is very good for Azure AI Search. And it has multiple ways. You can tell it. There is like 5 or 6 different ways. There is keyword, there is semantic, there is hybrid, which is both. There is a lot of different things. And they keep adding things to Azure AI Search for that as well, which is awesome. But right now, hybrid, I feel, is the best one. Whenever we run experimentation, it has the most accurate returns coming back when you combine the two together as well. This is the RAG data indexing vectorization example. So you can see on the left side, the data could be coming in from JSON files, from SQL tables, from Parquet files. So let's stop at Parquet files a little bit because this is a huge. So for instance, people sometimes have a huge Databricks or Snowflake or Microsoft Fabric data in the gigabyte, hundreds of gigabytes, sometimes terabytes worth of data, all right? So instead of actually trying to vectorize all the stuff, we can leave them in, let's say, Fabric or Databricks, for instance, all right? And then we will point the system to actually have access to this data directly to the one lake that has this data. It could be a data warehouse, it could be a one lake, it could be real-time intelligence, for instance, that have very small packets of data coming in every 5 minutes or 5 seconds, even from oil rigs and so on. But I want it to be available always to be part of the data that will be part of the search, whether it's hybrid and semantic search as well. You ingest this data coming in, you store it. Sometimes you go to a lot of tools like, for instance, Azure AI Factory and things like that, and you have an option of uploading files. You can do that, but this will have a life of 7 days unless you change the retention. Or you can actually open up a storage account in Azure and go create a blob, create a folder, and put your 200,000 documents inside of there and change your retention to 365 days or 7 years if the law requires that. And now you are in control of how long these files will stay there, all right? And each document will have a document ID as well, so that you can do that for the vectorization. It takes time, right? These things, you have to create pipelines for them because vectorizing 200,000 is not going to happen in a minute or two. It might take a full day to actually vectorize, embed and vectorize 200,000 documents. So I don't want it to be a surprise. I want to be able to monitor the pipeline. I want to find out how far are we. Are we getting any timeouts somewhere? Is the context window getting too much based on the data? All the stuff you have to be able to monitor these pipelines. And the enterprise is different than uploading a file and say, go, let's play some Toys R Us stuff. It takes time to do major vectorization for this type of stuff as well. And then the data storage. Some people actually always ask me, my data for the last 20 years in my company are inside of PostgreSQL, all right? Can I vectorize the data in Azure AI Search? And I'm like, why? It's like, because I heard Azure AI Search is very good. It does that very well. It's like, why? You have tabular data. PostgreSQL right now allows for embedding and vectorization. It is a vector store now. And you already paid the license for PostgreSQL. Why would you want to take the data out of there and go put it somewhere else where you have to pay another license? So you'll have to think about it a little bit. If you tell me that PostgreSQL have your data, but you're interested in the part that has PDFs, images, and docs, and CSV, maybe I'll tell you, okay, that part makes more sense maybe to put it in Azure AI Search, but you know why you have to do that. But if you have SQL Server, of course, this year has become a vector store as well. Vector store means you enable SQL Server to be a vector store, you create a new column, and tell it this will be the vector column. And now right next to it, there is the old description column that has too much text on each row. And I'm gonna say, like, I want you to take the entire text, which is each row have like a page and a half of description. Let's take that, let's go ahead and vectorize it. And the answer of the vectorization, I want you to put it in the next column. So now I can actually delete the description column altogether, to be honest with you. So whenever I have a question, it will be based on a semantic search in the 1536 dimensions on the one row for that. It would be a lot more powerful to find what you're looking for, even if it's not an exact match like we use in SQL. No, this will be a semantic search. It would be much, much more powerful to do it this way. Same thing you can do in Cosmos DB. Same thing you can do in PostgreSQL, not only SQL Server. Just remember, folks, when it's tabular, keep it in these things like PostgreSQL if your company is comfortable using open source. If they want to use SQL Server because this is what I've been using for a long time, there's no reason to leave that to keep your vectorization inside of there. So hopefully you always remember, Azure AI Search is great when the data is unstructured. That's it, all right? There are other things outside of Microsoft as well. There's Pinecone, there are things coming in from Bedrock, from AWS. Google Cloud also has a lot of different options for that. There are now hundreds of different vector stores you can use. There is a website called Supabase, all right? Supabase is a Postgres, so it's a SaaS model. You can actually log in, create a login, it will take you a minute, and then it will give you one database for free. So I can actually create a PostgreSQL database right away, and I can actually use it to go ahead and put all my vector stores in there, and that's a PostgreSQL. And you don't have to pay any money for it. If you want multiple databases, you want to exceed like the 2 GB limit, then you start having to pay. But just for testing this and see how it works, you can actually do a SaaS model, these databases, to use vector stores if you'd like. The rack completion example, all right, so the data store now have a lot of the information. And for me, like I said in the beginning, when I implement something from the customers, when I have tens of thousands of people using this, all right, I like to use Cosmos DB for the history, which has nothing to do with vectorization. This is not where the data is vectorized. This is just to keep the history. Because remember, if I go to any model right now, even the big ones, and I say, hi, it will come back and say, hi, how are you? How can I help you today? I says, my name is Lino Tadros. It says, hi, Lino, how can I help you? I says, what's my name? It's like, I have no clue. It has no clue what my name is. It's not part of the LLM to remember that. So you have to use orchestrator, things like semantic kernel and LangChain and others that are available in the industry today to be able to orchestrate all the stuff, to add the history, to add the caching. So what about caching? Caching is not history. History is a different story. History is to be able to remember the question and answer from the last 3, 4, 10, 15 questions and answer. But of course, the more we keep going, 20 questions with an answer, 30 questions and an answer, the next question is going to cost me a lot of money because I'm not only sending my questions, I'm asking my question plus all the question and answer from the previous history. So the tokens will get bigger and bigger and bigger. That's why we have something in the industry beside RAG. It's called the reducers. The reducers, there are multiple of them. There is one called the truncator reducers, which will actually say truncate only the last 10 history question and answer. I don't care anything above that, just drop it. I just want the last 10. That will be the history so that we don't have to spend too much money on tokens. And that's not a very good thing because it loses a lot of the meaning in the 12, 13, and 14 and the 20th questions. It doesn't remember any of that stuff. So the good one that a lot of people use is called the summarization reducer. Summarization means if I have 10 questions, instead of leaving them as is into the Cosmos DB or any other database, I will summarize the whole 10, maybe it will become less than half the size, and this is the part that I'm going to save. So when I retrieve it, I don't retrieve the whole thing, only the summarization of it. So all the noise that had nothing to do with the question, I don't have to save it, and that saves you a lot of the tokens as well. So these are what we call the reducers, which are very important as well. Make sense, everybody? You with me? The RAG limitation. I'm sorry for all the text. I don't like PowerPoint presentation or slides that have so much text, but I just wanted to show you the limitation with structured data. So that gentleman in the front can actually, probably want to take a picture of that, sir. This is the RAG limitation with structured data, right there, all righty? So RAG is particularly optimized for working with text data. It is less optimal for dealing with structured data, all right? So you can read all of the stuff. I talked about all of them already, but the scenarios of having structured data will be multi-turn. That means it requires the agent to go back and forth. That's not part of RAG. It's part of the agent itself. So you have to understand who does what in that world of agents and RAG and graph RAG and all of that. By converting the structure to text, you end up flattening and underlying similarity functions to be able to as it now, the examples have a lot of text components in them. For example, JSON. JSON is a big problem also because you can see JSON inside of SQL Server. But for the JSON arrays, for instance, do you want to flatten that out so that you can actually vectorize? You want to leave it as is? Do you want to have duplication for the JSON and the vectorized version of it, which can bloat actually the database? You have to think about all of these things as well. The vector databases, there is two things that I want you to remember based on the vector databases, the indexing portion and the query against it. And we talked about that. The indexing is taking whatever the embedder gives you and save it as is, and then you can load it at any time. Take the query, which is your prompt, your question, why is the sky blue? And it actually ends up embedding it as well and place it on top of the indexers to find out what is the closest thing that it can actually match to return back the semantic meaning of the question. So this is a graph as one for vector databases with embeddings. It starts with a document. Let's say it's a PDF. We have multiple pages, maybe 120 pages in it. Each page will actually get chunked into a shorter paragraph, which is the chunks. It will represent every single chunk with these 1,536 different floats that I told you about. And it will create vectors, as many as it needs to, maybe 400, maybe 1,000 different vectors for the entire 84 pages, for instance, of the PDF document. And then it will compare the embedding vector of the summaries with the embedding vector of the prompt that you just embedded as well, and it will return you the results that you can find based on the cosine and the similarity, how close it is for what you asked for. These are just a very small portion of the vector databases available today. You probably heard of something called ChromaDB, which is you can install on your machine to try it out, but you can also host it somewhere and run the ChromaDB. That's a vector database. Pinecone is a very famous one as well, that you can open an account on their website, pinecone.io. In just a minute, you can create an account and it will give you a free database that you can actually create an index and you can actually start putting in all your vector store from anywhere, from whatever is coming from an embedder, we can put it in there as well. Cosmos DB is a major database that will be able to do vectorization. Redis is a vector store. Azure AI Search is huge, especially for unstructured data. Azure PostgreSQL is excellent. A lot of people love using PostgreSQL. Quadrant, SharePoint, God forbid, also is a, no, I'm just kidding. SharePoint can actually be a vector database, but if you use it, God be with you. MS SQL Server has become, of course, a vector data store, so you definitely can use that. You don't have to go. A lot of people before they announced their Microsoft SQL Server being a vector store were complaining, saying like, everybody else is getting a vector store. We are the only ones that we have all our data in SQL Server, and to vectorize it, I have to take it outside and put it somewhere else. Why can't we just put it right in place and get it over with? And now we have all the stuff. And there are hundreds, literally hundreds of other databases that will allow you to do vector stores at this point. Some of them are local on your machine as well. All right, let's talk about the problems now. The RAG reality check. This graph or this slide is very important, folks, all righty? The brutal truth, 73% of retrieved chunks are irrelevant to the query. Let me repeat that. 73% of retrieved chunks are irrelevant to the query. Average response time is between 3 and 8 seconds. The users are expecting less than 2 seconds. Of course, if you're having a hello world with a document that has like 10 records in it, nothing problem. I'm talking about real enterprise level that has hundreds of thousands of things waiting 3 to 8 seconds just for the retrieval. It's too much for people to wait for sometimes. Context window waste, 60% of tokens are noise, are not the real thing that you asked about, because it's very far from the cosine and from the angle that you're getting stuff from, because you didn't do re-ranking or anything else, or the graph that we're going to talk about. Maintenance nightmare, stale data, broken references, the data changes too often every week, then you have to do all the stuff again. So it can be a problem with graph. So in reality, when the RAG fails, yes, sir, go for it.
Would port chunking also be a problem? Like,
Absolutely. Absolutely. And people always ask me, what is the correct number for the chunk? I says, if I knew that, I would be a millionaire. Nobody knows. It's all depending on your data. So when I go to a company, for instance, as a consultant, the only way I can answer that, I mean, some people say like, I use 1,000 characters for the chunk. It's like, why? Well, it looks like everybody's using 1,000 chunk, but it's up to your data. If your data is a markup or an HTML or whatever, I have to take a look. Are you using a lot of headings? If you're not using a lot of headings, maybe the character is the only thing we can do. But if you're in headings, there is a different chunking mechanism that will stop at a brand hashtag. Every time there is a hashtag, I want to stop and chunk, right? So one will be 200 characters, one will be 500 characters, and that's okay. But not all shoes fits all. You have to show me what the documents look like, and I'll tell you what probably the best way to do it is. Because not everything, just slap 500 characters on every chunk and we're done. What if your document is one page? Doing 1,000 characters, that means the whole thing would be one index. So you're always sending the whole document to the LLM anyway. Yes, sir.
What happens if you have data or different structures in the same document, tables and heads?
Yeah, as long as the table is text, it will do a good job. The problem that people usually ask me is different than your question. The question is like, the document has an image, and then text, and then another image, and the image has text inside of the image, all right? And then it has a table. The table and the text, the system will do a very good job. The problem is it can never get the data of the text. There is no OCR built in, all right? So it will skip everything in the image, it will not know. That's why when this happens, there are other tools that you have to run first before you run the RAG. Something from Microsoft, for instance, they have the Azure Document Intelligence. That means when you open up the PDF, if there is an image, I want you to take all the images and put them in an array, and then one by one, run the document intelligence to be able to OCR that, get all the text out of it, and place that text in where the other text around it was. Don't put it at the end of the document. No, I want you to take the text that you retrieve out of the image instead of the image when you RAG the whole thing. So it actually be very close. Yes, sir.
And it's working out the chunk size itself, using that word element.
No, you still have to create the chunk. There is an agent. People are creating MCP servers and agents to be able to look at your document and give you a recommendation what the chunk should be. And that's the part that's driving everybody crazy. Agents now are doing everything, all right? So even the prompt, there is agent that will create a prompt. So I can actually tell an agent, what I really want to ask is like why the sky is blue. So the prompt's like, no, don't ask it this way. That's too short. Let me give you a page and a half to ask the same question so you can get the best answer. So there is agents that will create prompts that know. For instance, if you use Sora 2 or Google the Veo 3.1, these are the ones that create the videos. There are now tools and agents that know all the guidelines of how to create a good video for 9 seconds or 12 seconds. So you can say like, I would like to create a video about a dog barking looking at the sunset. And what comes back is like, for Sora 2, you should actually put this one page to tell it exactly how to set up the stage, how to tell it, and you have to do a specific wording so the system can do it right. For Veo 3, this is what your prompt should do if that's what you're trying to get after. So it's becoming really amazing. You have to really find out how to actually ask the question based on the guidelines, how the model will react. Make sense? So when RAG fails, sparse and outdated data, ambiguous or multiple hop queries, domain language mismatch, poor retrieval quality, which is the hallucination, it can definitely happen. When we talk about knowledge graphs, folks, the knowledge graph retrieval, it actually looks at the 250,000 documents, for instance, and instead of vectorizing everything and just putting it on the graph, what it does, it creates what we call entities and communities. So you will have to give it some help in the beginning. Say like there are 4 categories in these 250,000 documents. Maybe let's say I have all the documentation from Azure. That's huge amount of documentation. And I'm going to tell my graph, there are 4 communities that I'm interested in. One of them is Entra ID. One is Azure AI Foundry. one, let's say, PostgreSQL, and one is Cosmos DB. Everything else, I'm not really very interested in. Now, take a look at all the 250,000 documents and put all these documents under these 4 categories. And then any word that comes up that is relative to that area, call it an entity. So now I have a big umbrella, and underneath that I have smaller umbrellas, which is the entities based on the categories. So when I ask a question about Entra ID, and it's all over the 250,000 documents, I can take a look at the entity and I can see all the chunks that are relative to Entra ID in here. So I'm not looking at 250,000, maybe I'm only looking at 50 or 60 or 100. So now when I ask a question, it will focus on this entity. So now it's not a huge amount of data that could have Entra ID galore, and I will miss a lot of good information because they are very far from each other. It's beyond the 10 answers that I asked for limit. So you see why graph is really great when it becomes really a matter of millions of documents and so on, creating these communities and entities and group them under a specific category that you design. There are agents now to actually help you by reading the 250,000 documents and then come back like, these are the 10 categories I recommend you create. All right? So even that, there are agents to do that now. So you don't even have to. But usually, if you know your documents, you can create the categories and then it will create all the entities for you by itself. Use relationship between chunks, enable multi-hop reasoning, improve contextual relevance beyond the flat vectors. And that's by combining them under the same entity. Agentic RAG lets agents think. That means orchestrate tools, retrievals, and steps, not just static queries. And that's the beauty of where we are right now with agents. And remember, always RAG is just one step inside of that agent. It has no way of looping. Only the agent can loop, not the RAG, the process, or the graph RAG process. Add reasoning and planning layers, use planners, memory, and tools for adaptive retrieval, and so on. The conclusion, really, before I give you a quick demo, we only have like about 10 minutes, but the conclusion, chunk smarter, with the questions I was asking, yes, you have to find the best chunking mechanism. There is a lot of them. Embed cleaner, retrieve better. Hybrid search beats single mode every time, okay? Hybrid, which means keyword and semantic search together. Agentic RAG adds memory, tools, and reasoning. Evaluation is continuous, not only, not a one-time thing. Garbage in, garbage out. Garbage in, garbage retrieve, clean your documents. And that's probably my main job in life right now. People think because I do a lot of AI, when I get hired, most of my time is spent on AI. Actually, it is not. Most of my time is cleaning the data for the customer, all right? That's the 90% of the job. And then doing the AI piece once the data is clean is not that difficult, to be honest with you, right? And remember, AI is big. Machine learning is inside of AI, and generative AI is a very small piece of machine learning. So usually, most of the time, I will be called in because people want to do generative AI, and I listen to their problem, and their problem is not a generative AI. It's a machine learning problem. All right? It's a regression or a clustering problem that can be solved with their own model done in machine learning. It has nothing to do with generative AI. But everybody now, based on the hoopla about generative AI, everything is a nail and you are the hammer. Everybody wants to use generative AI, but it's not. It's really a machine learning problem that they're trying to get. Groundedness beats guessing, all right? To be able to ground your data and your responses, to be able to get a score, it's called the F1 score, between 1 and 5, to find out if you have groundedness on the data that you're getting back. Use the right model for your use case. There are some models better at things than others. And that's one of the things I said in my other sessions as well, if you were there. GPT-5.1 is great. It's expensive, but it's great. But it's not great at everything. It's great at a lot of things, especially text is great, all right? That's why it's expensive. But the other models have been trying to compete with OpenAI, but they really finding hard to compete because there is so many billions of dollars being spent in there. So each one of the others have actually picked up a niche, say, okay, well, we cannot beat them for the next couple of years, but we cannot wait. Let's go ahead and beat them in one of two things to make sure that we have a market there. So you will notice that Google, for instance, focused very much on video indexing. For a long time, for the last maybe 18 months to 21 months, their video and all that stuff has been better than everybody else until a couple of weeks ago when Sora 2 came out. That was a problem for Google, so they have to release 3.1 that meets all the new stuff that Sora 2 did. So notice there is competition in it, but they want to meet them. When people ask me, for instance, I want something that helps me with code and I write in Python. Can GPT 5.1 help me with Python? Sure, it can. It can actually give you a pretty decent one. Is it the best one for Python? No, it is not. Grok 4 currently. I don't know about next week because that changes so fast. Grok 4 is the best one for that. I'm writing JavaScript and TypeScript code. Well, GPT 5.1 can do the job. Oh, so sure, it can do the job. But Sonnet 4.5, coming in from Anthropic, is known to be the best JavaScript generator out there. So you'll notice you have to now create different agents, and each agent can use a completely different model. So this one is good at that. Let's go ahead and use Sonnet. This one can use Olama because it's only have a couple of PDFs for the happy hour for the restaurants. We don't need something big. But this one, GPT 5.1, because it has the resort itself here for the hotel. For instance, it knows a lot about what's going on in the hotel, so we will help with that. So you can see that you can start your application, and while the application is running, these agents can use a completely different model, completely different LLM while they're talking to each other. You don't have to stick with one LLM for the entire request. You can ask a question, wait a few seconds, and you have used 4 different LLMs with 4 different agents to get the answer. There is nothing wrong with that, and it can save you a lot of money instead of always going to Publix, get a glass of milk with a 747 jumbo jet. Feedback makes RAG smarter over time. So feedback, you probably saw this in ChatGPT and others. When you ask a question and you like the answer, don't forget to give it a thumbs up. And if you don't like the answer, like, oh, that was very bad, give it a thumbs down. When the next time they're going to train this model, they're going to take that into effect. They're going to take all the feedback and they're going to RAG that into the new model as well. When they do the creation or the fine-tuning of the model itself, they want to find out whenever we answer that question, 90% of the people thought it was not a good answer. So we need to remove the data that it was, the citations that was based, that caused that answer to come back. So we don't actually have to make the next problem occur in 5.2, now that we have 5.1, and so on. So don't forget to do feedbacks because they take that into consideration as well. So I actually, instead of writing code, I just wanted to show, because a lot of people here told me that they are not really, main job is not development, they just want to understand what vectorization is all about. So I'm going to open up this, and this is a visual way to actually do embedding and vectorization so you can understand it. This is a product called Flowwise. There is another one called N8N. Both of them are great for doing that stuff visually without writing any code. So if I go, for instance, I would like to create a visual agent on the fly. So I'm going to say, let's go ahead and create a brand new flow for that. I'm going to start from here. Let me bring this guy to the left. And then I'm going to say I'd like to bring in an agent. So we'll say, let me bring an agent in here. And then I'm going to hook the start to that so I can run the entire flow. Oops. Let me click on this guy, bring it in here, okay? And then let's double click this agent. I can give it a new name if I want to, but I'm going to tell it which model to use. And you can use from AWS, from Azure, OpenAI, from Anthropic. They have all the big ones, the Cohere, everything. So I'm going to look for one, like let's say the OpenAI, directly through OpenAI. And then for the parameters, I need to connect. That means I need to go get an API key from my platform.openai.com, and I need to put it in here. I already done that, so I don't waste a lot of time. I already have my API key set. And then you'll have access to all the models that come in directly from OpenAI, 5 mini, Nano, 4.1. Let's say we'll use, for instance, 4.1 mini. How about that? All righty? And it's actually bringing this in right now. And then we'll set the temperature. And I talked about temperature in the beginning of the session. So whether between 0 and 1, let's say it's 0.2 to make it pretty close to the exact meaning of what I mean. And I'm going to turn on streaming, so it does not have to bit the answer. It will bring in every token so you can see the streaming for the answers coming one. And I'm going to leave everything else the same. I'm not going to change anything for the agent. I can save this. Let me click in here and say save. And I will call it Lino, for instance, just to give it a name. Oops, sorry. What did I do? Let's click on this guy and we'll say Lino. There you go. And we'll say save. All right. So that's my workflow. I can run it right now and I can see returning something. So I can come in here and I can actually ask it a question, say, why is the sky blue? And now my model is, my agent that uses a model, GPT 4.1 mini, is going to answer that question. Let me wait for it to come back. There we go. Today, be nice. Oh, we don't, oh, yeah, there's no internet, folks. The internet went down. That's very nice. Yep, there is no internet. Okay, so I want you to imagine with me that this worked. All right? But while this is not going to work, but at least let me show you also how to do the vector stores and the embedding. So visually, so I can go to something like document store, for instance, and let's go ahead and create a brand new document store in here. I will call it, for instance, Florida DMV, because I have a PDF that I downloaded from Florida here that has 120 pages for how to get a license, what are the rules of driving a car in Florida. 120 pages. This is how you read it so you can go get the exam here in Florida at the DMV. So we'll say add this document store, and then I'll open up this Florida DMV. So like I did before, ingestion, chunking, embedding, and indexing. Same thing has to happen here, whether you're doing it in code or doing it visually. So I'm going to add the document right there. And you can actually bring the document from so many places like Airtable, a REST API, Confluence, a web scraper, CSV files, Microsoft Word documents. I'm looking for something that has to do maybe with PDFs. And there is one. There is the PDF one in here. I'm going to upload my file. And there it is. That is the PDF for the Florida DMV. Let me upload it. And then it will tell me how do you want to use it. You want to create one document per page or one per file? I'm going to say one per page. That means I'm going to have 120 documents that will need to be chunked at this point. So if I go down a little bit, it will ask you how do you want to split. That means how do you want to chunk it. And like I told you, there is a lot of different ways. I can say character splitter, code text splitter, HTML markup token splitter, recursive character text splitter, which is for a lot of things is the best one that you should start with to try out. And then you can specify what each chunk should be. So you can try with 500, 1,000, 2,000 based on the data. Take a look at the data and make that choice as well. So once I do that, I'm going to say go ahead and preview the chunks. And now I did two things. I did the ingestion and I did the chunks. So actually my 120 pages ended up being 297 different chunks. And it will give you a sample of what the chunks look like. All right, let's go ahead and process it. And that will take hopefully about maybe 20 seconds or so to do the job. So it will say 0 now, but refresh the page after a few seconds and it should do it. Yeah, it's done. It's about 250,000 characters inside of that document, 297 chunks. I only did half the job right now. I just did the ingestion and the chunking. Now I need to do the two interesting one that cost money, the embedding and the vectorization. So the way to do that, we click in here, for instance, we'll say upsert all the chunks. And now there are three things we need to do. First of all, we need to select an embedder, and then I'm going to select the vector store, and then I might do it or not, which is the record manager, depending on the database. So I'm going to say, let's select the embedder first. And again, there are a lot of embedding models out there. OpenAI have 3 of them, ADA002, 3 small, 3 large. Cohere have some, IBM Watson has some. Hugging Face have a lot. So you get to choose which one you want based on that. I'm going to go with the OpenAI embedding because I have access to it. I'm going to use the same credentials that I used before, OpenAI key. And the model number, remember I said there are 3 available from OpenAI. So I'm going to bring this down, hopefully, and it will loading. It should show us the 3 of them. Oh, I'm never going to see it. There is no internet. Let me see if I can do this on my phone. I will tether it on my phone. There's no time, folks, but there's no time. There's 1 minute left. Oh, it came back. Thank you. All right, so I'm going to say I'm going to use the 3 large, for instance. Sounds good? And I can leave everything else the same. It's okay. I'm going to go to the selected vector store. And even that one, there are tons, hundreds of different vector stores. PostgreSQL, MongoDB, ChromaDB, Pinecone. Let's say Pinecone, for instance, in here. I already have I got the API key for Pinecone, so I have it access. And I created an index that's empty. There is nothing in it. I called it Florida DMV, I think. Yes. And I didn't have a namespace or anything. I'm going to leave everything with the chunking, the same thing for the Pinecone. And I'm not going to use a record manager. Record manager is important, folks. If tomorrow something changes, I don't want to redo all the stuff. Record manager will remember the document ID, so it can actually take out the one that changed and it puts in the new one without actually having to do all the embedding on the ones that have not changed. So this is very important. I'm going to save the config in here, folks, and I'm going to say upsert. And what's happening right now is going to take a couple of minutes. It's going to take all these 297 and it's going to put them in Pinecone, and I can go verify them in Pinecone. And now I can go back and start asking questions by pointing to this vector store called Florida DMV. And any questions I'm going to ask, it will embed my questions and it will give me an answer from my document. And it could be 10, 20, 100 documents, not only the Florida DMV. And I can turn on citation so it tells me my answer came from which documents and from which chunk in the document. So for healthcare and tech companies, that's very important for them to show you a proof. Why did I say that answer? Because these documents and these chunks told me to answer this way. So having proof, the citations are very important, all right? Unfortunately, the internet doesn't love me today, and Cloudflare, thank you very much. But other than that, I want to thank you all for being here. This was my last session in the conference, but I enjoyed it very much. Have a wonderful conference. Thank you very much.